Hello everyone, this is Dr. R. Jefferson George, and this is week 7 of EDLE 6110. And so we're going to start a little differently this time. I wanted to go through the readings for this week, and maybe that will be helpful. Check my audio here real quick. Audio looks good. My on-screen is looking good. So, all right, we'll continue the recording. We'll minimize this, get out of the way. And so this week we're going to back up just a little bit, go back to chapter 6 and take a quick look at z-scores, because z-scores, just to remind us what a z-score is. A z-score is a score with a mean of 0 and a standard deviation of 1. And this helps us because it standardizes all of our data and places it within a normal distribution. And so we do use the probability theory, and I put in here Gaussian, but it's the basis of all of our statistics, and it's basically what we use. And if we go down a little bit further here, we look at 68%. The probability is that 68% of all of your data will fall within plus or minus 1 standard deviation of the mean. It goes up to 95%. Will fall within 2 standard deviations of the mean. That means it'll go over here to -2 and it'll go over here to +2. And so 95% of your data will fall in between this. So when your data falls outside of the second standard deviations, 2 standard deviations from the mean, well, then we have some level of significance about your data. And 2 standard deviations to 3 would give us 0.05, or it would say that there's only a 5% chance that your data occurred out here just by chance. And then if we move on out to 3 standard deviations plus or minus from the mean, then we're saying that there's only a 1% chance that your data occurred way out here that far away from the mean. So z-scores are a way of taking any set of data and standardizing it into the normal distribution and providing a mean of 0 and a standard deviation of 1. So just to remind us of that, because we can take I have an explanation here, but we have a formula that we can use. So a z-score might be a student score minus the mean score divided by the standard deviation. And then you could take that, whatever that score was, and then you could find it here on our normal distribution curve. And so if we were talking about means, sample means, then we could do the same thing with sample means. We could take a sample mean minus the population mean and divide that by the population standard deviation. And we could also come up with a place to put our data on the score. So we could compare, that way we would give us an opportunity to compare means. And when we start doing something like that, we'll start looking at something like, we're going to think about z-scores, and then we're going to change that to t-scores. And so I'm looking at a misspelled word right there, but in quantitative research, we use data from a sample to test our hypothesis. And so that's what we do. When our data is significantly different from the claim of no difference, we have a null hypothesis, then we were able to say that our data, because it is significantly different, meets our research criteria, and we can continue on and say that, so that our data meets our research criteria. And so then there's a couple of little definitions we want to remind ourselves of. Degrees of freedom. Degrees of freedom, that's the number of values in your sample that are free to vary. That means be used by the system. And for our purposes here, it is necessary to remember that degrees of freedom equals a sample size minus 1. And the minus 1 is just to make sure that we don't make any errors. And so we go ahead and subtract 1 from the very beginning, because the final degree of freedom, the final part of the sample size, it's not free to vary, because it's the final result. And so so we'll just take that one out and not use it. And so, but it's important for us to remember, though, degrees of freedom equals the sample size minus 1. Our t-statistic, remember to calculate your z-score, You need to know the standard deviation or the variance of the population. Without a standard deviation, we cannot calculate the standard error and cannot calculate the expected difference between the sample mean and the population mean. So when the population standard deviation is absent, then we have to use a t-statistic instead of a z-score. And the t-statistic allows us to estimate the standard error of a population by using the sample standard deviation. And so that, just to keep that in mind, the definition. And then your book had some very good examples. And so I took one of the examples, and this is what I'm going to do in the video today, is I'm going to show you this particular example. I believe it's on page, starts on page, hang on. Starts on page 77. Didn't have my marker in there. So we're going to do a one samples t-test. And so the first thing we want to do is to state our research hypothesis. And so we're going to say the mean GPA of our high school seniors is not significantly different from the county GPA of 2.5. So we know the county GPA, but we don't have a set of data to support it. We've just been given the county GPA. And so the mean GPA of our high school seniors is significantly different from the county GPA of 2.5. And so the null hypothesis says it's not significantly different. Our research hypothesis says that it is significantly different. So the reason here we have, and now we have this thing called degrees of freedom. So we look at our data, and in our data we have 20 students and 20 scores. And so that will be our sample. And so N would be 20. We're going to say minus 1, so that would be equal to 19. So and then we're going to set a level, an alpha level, or the level of our probability, that level of significance that we're looking for is 0.05. And so we go back to the back of our book on page 180, and we look at that and we say, okay, we have a significance level of 0.05, and we have 19 degrees of freedom. Then what is going to be our critical value? And we look at our table and it tells us our critical value is 2.09. And so in a minute, we're going to look at the video and analyze the data. But when we analyze the data, we're going to find a t-value of 3.89. And that value of 3.89 is significantly different from 2.09. And so we're going to reject the null hypothesis, accept the research hypothesis, and then we'll determine that our GPA of our seniors is significantly higher than the county average. So now that we've kind of gone over that, let me move over here to SPSS, and we'll look at our one samples test. And so again, on page 77, there is a table 6.1 that has the data in there, and I've taken the data. Look at the variable view first, and I have put in the name of the variable here, GPA. It's numeric data. I've given it 2 decimal places. And if we go over here, and it is a scale. So make sure that you set that up properly. And then look at the data when you enter your data, because I would practice this on your own. That's what I would do. And here's your scale. Here's your variable. And then here are the 20 students and their GPA scores that are on page 77. And so you can copy those and put them into your SPSS data editor. And so then what do we need to do? Well, we're going to do a one sample t-test. And so the way we do that, not so difficult now that we have our data entered, is go to Analyze, click Analyze, come down to Compare Means. And if you look there, you'll see you have means, one sample t-test, independent samples t-test, summary, paired samples t-test, and a one-way ANOVA. And so but today we're just doing the one samples t-test. So you can click on that, and your data will come up with GPA on the left-hand side. And so you want to move GPA to the right-hand side because that says test variable, and so that's what we're going to put there. We know that the county GPA was 2.5, and so we're going to put that in the test value. So that, and then we're going to look at options, and options is going to be 95% because that's what we're looking for. 0.05 level of significance or 95% confidence interval. So we're going to say continue on that. And then we're going to say okay. And so if we look here, it was going to give us a one samples t-test, and it's going to give us a t-value of 3.887, which is what we came up with. Degrees of freedom 19, a level of significance of 0.001, so well past 0.5, and mean difference of 0.245. And then I'm just going to let you know right here where it says 95% confidence interval. This is different from the book, and I'm going to tell you the book is just not correct. And so I went through several analysis to find out what was the correct answer. It looks like somehow in the book they used 93% confidence interval, and then just mistyped the information. So this is what comes up in SPSS. And so if we're looking at, here's our one samples t-test. Here's 20, n of 20, a mean of 2.7450, standard deviation of 0.281, and the standard error is 0.063. And then again, here is 3.887, degrees of freedom 19, significance level is 0.001, mean difference is 0.245, and here are our upper and lower confidence interval levels at 95% confidence interval. So that looked like it worked pretty well, and you should be able to do that without any problems. In your application activity, be sure to do the application activity on page 80, and you'll just, you don't have to do a lot of analysis, but you will have to think about how to answer that question, and then write a short paragraph about how to answer that question, and then that'll be submitted along with your other assignment. So in chapter 7, we have the independent samples t-test. So in this case, let's go back and look at some of our information here. It says, but what if we have two data sets? And then we actually did have two data sets before, but we didn't really have a data set. We just had the average that was the mean that was determined for us. So in the independent samples t-test, we're going to determine the output ourselves for two complete sets of data, and then follow a similar procedure to analyze the data. And so I just outlined the procedure here. We're going to state our research hypothesis in the form of a hypothesis, our research question in the form of a hypothesis. And our research question or hypothesis is that the sample means from two groups of university students are not equal and will be statistically significantly different from each other. And then we have, so that's our research hypothesis. And so we're going to decide the criteria for making a decision. And so remembering now that we have two separate data sets, we're going to also have two separate degrees of freedom. So that would make a slight difference, because if we used 40, we would end up with 39 degrees of freedom, but we have two data sets, and so we really have to use n-1 plus n-1 equals 20 minus 1 plus 20 minus 1, or 19 plus 19, and gives you 38 degrees of freedom, instead of doing it all as one data set, which would have given you 39. So if you look that up on the table, on the t-distribution table on page 180, use an alpha level of 0.05. We see that 38 degrees of freedom at an alpha level of 0.05 is 2.03. And this means that the resulting t-value from our analysis needs to be 2.03 or greater to be considered statistically significant. So we're going to analyze our data, and we're going to use the data that we find on table 7.1, which is on page 91 in your textbook. So you can copy that data into SPSS and create your own data file. And you'll notice how this data file is a little bit different, because if you're looking at page 91, then it gives you a student number, and the numbers are 1 through 40. The universities are listed as A, and then university B, and then each student has a score. And of course, you know that SPSS wouldn't be able to use A or B, so you'll have to change the A, and I changed the A to 1. I coded it as 1, and I changed the B to 2. But also, when I set this up, I'll show you how to do that in just a minute. I coded that as string data, so because it's certainly not a scale, and it's not really numerical data. It's really just acknowledging that this is one university and this is another. And so, so how do we do that? Well, then, so now that we have our data in our thing, then we can make a decision about our data. So we're going to run our data, analyze our data, and then we're going to make a decision about our data. And so how do we do that in SPSS? Well, it tells you, here we have a few directions. First, select Analyze, and I'll go over it in just a second. Select Compare Means, select Independent Samples t-test. Then we're going to define those variables just like I just told you, A equals 1 and B equals 2. Select Continue, and then select OK. And then we'll talk about the results. So, and then in Canvas, I'll highlight this video and I'll put the video right here. So let's go over and look at SPSS again. And this time we'll look at our independent samples t-test. And just like I was telling you, first let's look at our variables. So we have our university variable here, put the name here. The type of variable is string. So we're not going to code it as numeric. And it's also nominal. So it's just the name of something. And so, and then the exam score is our second variable. It is numeric, and it is a scale. And so then when we look at data view, our data view here, you'll notice that here's university, and 1 through 20 is now coded 1, and 21 through 40 is now coded 2. So 1 is university A, and 2 is university B. And then here in your exam scores, each student, I inputted their exam scores and built my data set. So, and I think it's important that you do that. And so build your data set, become a little more familiar with how to input this information. And then, so now remember we're doing an independent samples t-test. So easy enough this time, go to Analyze, go to Compare Means, and then if you come over here to Independent Samples t-test, we'll click that. So when it comes up on your computer, you should see exam score. And so take the exam score and put it into the test variables section. And your grouping variables will be the university. And so I'm going to move those back. So university, and then we're going to move them over here. And look, you have question marks right here. And so we're going to define groups. So group 1 is university A, which we've coded as 1. And then group 2 is university B, which we've coded as 2. And then once you click continue, it inputs your variables there, and that's how you define those groups. If you want to check, in this one, you can see it still has a 95% confidence level. So we can say continue, and you come down here and say continue or say okay again. And look at our output. Yeah, so here's our t-test. Here are our group statistics showing us that our exam scores come under University A, University B. Each one of them has an N of 20. The mean is 83.65. The mean of University B is 77.25. There's a standard deviation. So University A, the scores are closer together, and University B, the scores are further apart. And also you see the standard error, 1.84 and 2.38. And we can look down here and see our F value is 3.0. 747. Significance is 0.06, and a T is 2.123, and degrees of freedom 38. Here's a two-tailed 0.040, our mean difference, our standard error, and then our 95% confidence interval of the difference. And so when we take a look at that, we are looking at the variables that they have in here, but making sure that his were the same as ours, but they are. And so if we're looking at a significance level of 0.01, well, that's larger than 0.01. And if we're looking at a significance level of 0.05, that's larger than 0.05. So I would have to say this was not the difference between the two universities was not significant. And so but if we look at our observed t-value, the t-value, and we compare the two universities, the two-tailed probability is 0.04. And so let's look over here, and so this would give us a better indication. The significance of the two-tailed t-test would give us a better indication of significance. So it's 0.04, and since it's less than our previously selected criteria of 0.05, which allows us to consider the difference and significance of the two scores, I would say that in this case, the University A was significantly different than University B, although even though we're looking at the means, the significance is still very small. And so we look up at the means in the group statistics, we see a mean of 83.6 in University A and a mean of 77.25 in University B, but the level of significance between those scores is actually very small, but still available. So remember that you're looking at your t-statistic, and your t-statistic is greater than the level, the t-statistic that we were looking for, which I remember was 2.123, and our t-statistic is 2.123, and we were looking to be greater than a t-statistic of 2.03, and so we are, but just not by very much. So these are the two t-tests that we're running today and the analysis of those t-tests. I think you guys will be able to do a great job. What I want you to do in your assignment is to go back to the application activity on page 100 and go ahead and input this data and perform this activity, and let me know what you find in terms of being able to explain and to analyze and to explain if there is a statistically significant difference in the two scores. The two kinds of instruction 1 and instruction 2, and looks like you have 20 students. So I was just going to suggest, don't forget to look up your, go to page 180 on your t-distribution table, and be sure to look up your t-value and at the 0.05 level. And remember that you have actually two sets of data. So although there are 20 students, you really have two sets of 10 students. And so you're really looking at a degrees of freedom of 9 plus 9, which is 18, rather than 19. So that would make a difference in your t-distribution table, and it'll make a difference in your t-score that you're looking for. So please don't hesitate to email or call if you have any questions, and I'll look forward to seeing what you guys come up with. So have a great day.